Today, we're going to be learning about linear programming. Our situation is that food and clothing are being sent by commercial airplanes to hurricane victims in Florida. Each container of food is estimated to feed 12 people. Each container of clothing is intended to help 5 people. Organizers of the relief effort want to determine the number of containers of food and clothing that should be sent in each plane shipment that will maximize the number of victims helped. So the first thing we need to do is determine our variables. I'm going to use X and Y. The two things that we want to figure out is how much food and how much clothing we should send. So I'm going to have X be containers of food and Y be containers of clothing. Next, we need to write an equation that expresses the number n of victims that would be helped in terms of y. And this is called our objective function, which is an equation used to determine the possible outcomes. In this situation, it would be n equals, and then 12x, because each container of food helps 12 people, plus 5y, because each container of clothing helps 5 people. Next, it tells us some restrictions, because we can't just load up the plane with as much stuff as we want. We have limits on how much weight and how much space there is on the plane. So the weight and space restrictions imposed by the airlines are summarized as follows. The total weight of the supplies cannot exceed 19,000 pounds, and the total volume must be no more than 8,000 cubic feet. Each container of food weighs 50 pounds and occupies 20 cubic feet of space. Each container of clothing weighs 20 pounds and has a volume of 10 cubic feet. Now you might be saying that that's a lot of information and a lot of numbers, but we're going to break it down piece by piece. So what we're going to end up writing are called constraints. These are our restrictions, and they are written as inequalities. So first, let's look at the weight restrictions. The total weight cannot exceed 19,000 pounds. So we know that it has to be less than or equal to 19,000 pounds. We know that food weighs 50 pounds and clothing weighs 20 pounds. So 50x plus 20y is what needs to be less than 19,000. Next, let's look at the space restrictions, or the volume. So the total volume can be no more than 8,000 cubic feet. So we have less than or equal to 8,000. And then we know that food occupies 20 cubic feet each, and the clothing is 20 cubic feet each. So 20x plus 10y has to be less than or equal to 8,000. Finally, we can't have a negative number of containers. It has to be 0 or more. So we need to say that x has to be greater than or equal to 0, and y has to be greater than or equal to 0. Next, we need to find our feasible region. So this is the overlapped area. of all the constraints. So we're going to graph all the constraints and see where they overlap. And that will be our feasible region. And we're going to do this today in Desmos. So I'm going to put in all 4 of my inequalities. So see how that one made it really dark because they selected black for this inequality? If you go up to the gear, then you can click on it and change it to a color. That makes things a little bit easier to see. So I'm looking for where these 4 intersect, which is in this, it's almost a triangle, but it does still have 4 sides. In that area right in there. And what we ultimately want to find are the corner points of this, because they're going to be the ones that we're going to plug into the objective function, because the corner points are where the maximum is going to occur. So if I'm looking for, there's one corner, there's another corner, there's my other 2 corners. So those are going to be my corner points that I'm going to put in this table. Then I'm going to plug each of these coordinates into my objective function that we wrote at the beginning. And when I plug these into my calculator, the first one I get 0, then 4,000, third one gives me 4,560, and the last one gives me 4,600. So now we need to go back and answer the original question. What is the maximum number of hurricane victims that can be helped per shipment? Well, our coordinate that we put in the bottom row of our table came out to have the highest value in our objective function. So we would say they should send 300 food containers and 200 clothing containers to help a maximum of 4,600 people. That's all for today. I'll see you in class.